Today we're going to be doing merge two sorted lists. We're part of the linked list section. Done a bunch of these. I find I really struggle with linked lists, but we'll go from here. So, anyways, merge two sorted lists. So you're given the heads of two sorted linked lists, list one and list two. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Okay, so 1, 2, 4, and 1, 3, 4 gives you 1, 1, 2, 3, 4, 4. Cool. So first we'll make the merged list. So merged is equal to new list node. And I'm going to make a result one because this new one will start off with 0. It starts off with the 0, and then it would be the sorted list or merged list after, merged lists like that. So I'm going to make a result, which is just going to be pointed to merged. So it's also like the merged head. I could call it merged head. So what we'll do, so we'll make pointers for each list. So list node L1 is equal to list 1. And we'll do list node L2 is equal to list 2. So while L1 does not equal null, so while the pointer is not null, we're going to check the value. So if L1.val is less than or equal to L2.val, what we're going to do is, so list 1's value, so let me put a comment here for the example. So we have list 1, and that's going to be 1, 2, 4, and then list 2 is equal to 1, 3, 4, if I'm not mistaken. Yeah. Okay, so list 1's val is going to be less than or equal to because, it could be the same. If it is, we're just going to arbitrarily pick list 1's value to be added. So merged dot next is equal to list or L1. Then we have to increment L1 because this has been added to the resulting list, and now our pointer needs to move to this value. So then we're going to do L1 is equal to L1 dot next. Otherwise, otherwise we'll do merged dot next is equal to L2, and then L2 is equal to L2 dot next. And then also we're just going to increment merged, right? And then return the result dot next because it's the dummy connection. It's the merged head pointer, and we're skipping the first element. Oops. Okay, now there's a couple of edge cases here. What happens if list 1 becomes null? So it's not necessarily it's like this, it could be like this, right? So in this case, like if list 1 is null, right, we've finished it. Whatever's left in list 2, since it's already sorted, would just be thrown into the merged list. So we'll do a check here, or we'll just do merged dot next is equal to L2, and we'll just get the rest of the list. Right. Then, but what about if the other case, where instead of it's like this, we have L2 is, we don't have any L2. We'll just want to take all of L1. So then we'll do a check here. If L2 is equal to null, then we're just going to do merged dot next is equal to L1. And we're going to break because there's no point in being anything. We're done with that. But actually, this isn't done because we have to do, if L2, sorry, this is, if L2 is not null. Because it could be that, we finished all of L2 and we added all of L1. We don't want it to just put L2 at the end, right? It would be null. We want to um, check if L2 is not equal to null. Then we set the merged value. Otherwise, and then we're done here. We just return result.next. Let's run it. So that looks good, and then submit and accepted. Cool. Looks like we're about average beats half in memory, and runtime. It doesn't. I don't really understand, but that's fine. Thanks.